So yesterday we were looking at the programming languages. Yeah, Rani, actually, I will upload the recording of yesterday's class. Yes, Swat is asking what is the difference between Java and JavaScript. Java and JavaScript are entirely different languages. Java is a object-oriented programming language. Java is a compiled language. JavaScript is a scripting language. JavaScript only works in the browsers. So it is a scripting language. It is not object-oriented. It is object-based language. The reason why JavaScript was named JavaScript is actually JavaScript is created by Netscape Navigator. If you remember the browser which made Netscape Navigator. So Netscape company created JavaScript. So to create this language, they didn't have this expertise. So they have to call people from Sun Microsystems. So the people from Sun Microsystems came and developed a language for Netscape. So if someone comes from Sun Microsystem, what will they name? They name it based upon Java. So that is why it is called JavaScript. But it has nothing related to Java other than that relation. Okay. Alright. So coming back again, let's look at what we have learned yesterday. So there are two kinds of languages that can be, in many ways we can differentiate languages. One is procedural versus object oriented. Procedural means writing functions. We don't care on what entity we are doing that function. We just see programming or using software or anything is all about using something like, I will go and click file open, file close. So it's all about doing something. Doing something is nothing but in programming it will be a method or function. So procedural means writing a sequence of methods or functions. Okay. So that is procedural. Object oriented means it's not only about functions. These functions are encapsulated into an entity. See, for example, like let's say we are closing a document. So closing is a function on the document. So document is an entity, closing is a function on the document. Agreed? So defining entities and defining functions on the entities rather than functions individually, we create functions and methods on the entities. So when you take that approach, see, this is an approach. The programming is same. Finally, when you do programming, like when you write if-else block or something, it is same. But how we approach programming is different in object-oriented programming, and how we approach it will be different in procedural. So that is the major difference. So I don't know, have you written a procedure in PLSQL? Anyone? Did you see how to write a procedure? Did you see how to write a function? Did we do PLSQL? No. Okay. Alright. No problem. Okay. I will keep that in mind. Okay. Alright. So C language, PLSQL, or all the old languages mostly are procedural languages. They are all procedural. Object oriented languages are C#, Java, C++, or some of them are object oriented. Okay. And there are two types of languages. Languages can be differentiated on how we convert them into binary code. For example, there is a compilation language or scripting language. Compilation language means you have a code. For example, you write code in Java. You can't just run it. You need to compile this code into, for example, let's say C++ actually. You have, or C++ or C. Okay. You have code. You need to compile this into binary. And then you will run this. Then you will run it. So compilation needs to be done. So the code needs to be compiled before running this. Okay, that is C++ or C. And then there is scripting languages. Scripting languages are lightweight languages. Yes, they are lightweight. Why? What do you mean by lightweight? Can anyone explain me? They are really not meant to do huge programming. Or what is huge programming mean? Okay, let's say it doesn't do much stuff. It doesn't really go the beneath of the system to do something. What does it mean? Means it really works on something else. For example, lightweight programs are like, for example, shell scripting. Shell scripting is nothing but scripting the Unix commands. So already the Unix commands are there, we are just scripting the Unix commands, right? So we are not recreating something, we are not really defining the functions, or we are not really working with the hardware, we are not really working with the operating system fundamentals. We are just using the commands, and we are just writing some scripting around it. Agreed? So for example, coming back to JavaScript works on browsers. So browser itself is a program to tweak that program. For example, see, sometimes you get emails like, on JavaScript there will be a mosquito fly or something. You can't catch it. If you move the mouse over the mosquito, it will be moving here. So this kind of pop-ups and everything, all the animation sometimes will be done using JavaScript. So JavaScript is nothing but browser is giving so much of functionality. Browser gives pop-up, browser gives mouse events. This all, see, if you click this, it is an event. If you move this, it is an event. So this is all defined in the browser itself, because you are doing this on the browser. So you can do this by user, or you can do this by program. That program, the language which browsers understand is JavaScript. Okay, so you can, all the browsers are supposed to understand JavaScript, because JavaScript is ECMA compliant. Okay, so every browser will understand JavaScript. So scripting languages are working on already some programs. So they are not really, we are not really creating softwares using them. They are really lightweight. So they are working on something else. So they can't do much of the stuff which compiled languages can do. Okay, because compiled language is binary. It's itself a program. Sometimes it doesn't need an operating system to. For example, see, if there is a hard drive, you can write a program how to talk to hard drive in binary. You don't need a Windows operating system for that. Agreed? So that is the difference between compilation and scripting languages. Compilation languages are more powerful. And the next thing is platform independent and platform dependent. Independent and platform dependent. See, right now we have so many operating systems. Of course, they are not many popular. Only like we can count on fingers, like Windows, Mac, Unix, Linux, iOS, and Android, which are more popular. But still, when you create a software and if you compile that program, see, this is only for compilation programs. See, scripting languages is different. So compiled programs. Okay, compiled programs. For example, if I write a program and if I compile it, I want it to run everywhere. I don't care if it is a Mac or Windows or Unix. Means I compiled it. It's binary. It should run. But remember, binary is different for Windows. Binary is different. The same binary cannot be used on Mac. So any binary which is there for Windows, because see, operating systems are platforms. They have their own way to understand things. So so the code written for Windows will not be useful for the Mac software, Mac operating system. So if you write a program in C language and if you compile it on Windows machine, it will run only on Windows. And again, even in Windows, there are many types of operating system like Windows 7, Windows XP, Windows Server 2008, Windows 8 mobile. Like there are many kind of operating systems. So if you compile a program for particular version of Windows, it may not work for other version of Windows itself. So these are called platform dependent programs. So you need to compile it for every type of operating system. But generally, for example, let's say, it might be good for software. For example, when you are going and downloading Notepad, you will download Notepad for Mac is different, Notepad for Windows is different. But when you are doing like small applications, you want some generic. For example, let's say I want to go to Bank of America site. Okay, going to the simple site, it doesn't have to be platform dependent, or for example, let's say any small applications, it doesn't have to be platform dependent. So Java brought actually the platform, it's not completely Java, but Java is the one which made the platform independence popular. Okay, so see, C is compiled, C++ is compiled. Okay, C++ is object oriented. I will come regarding the history. So platform independent, Means, see, before, like when you compile C program, I have a C program, let's say I have a C program, and I will compile it. What will you get it? I will get binary. So this binary is particular for an operating system, binary for Windows, binary for Mac, binary for other operating system. But when you compile Java program, and you compile it on Windows, you will not get binary. You will get bytecode. Bytecode. What is this called? Intermediate language. So this is another language. Who created this language? Sun Microsystem only created. The same team who created Java program also created Java language. Also created another language. So think like, for example, let's say for example you understand one language. So for example, I am writing my program is in different language. So if I have to give you this program, I have to convert it into your language, right? But think like I write a program. I write, for example, like let's say I write a program that is called JRE. So if there is JRE on any machine, bytecode can run on that machine. Okay. So for example, there are 10 different languages, but you only understand one language. Okay. You only understand one language. So, but we create a platform, we can install this platform on any machine. If this platform is there, Java program can run. This bytecode can run. So, when you compile a Java program, you get a bytecode. This bytecode can run on any machine as long as there is JRE on that machine. Agreed? So bytecode can run on any machine as long as there is JRE on that machine. So JRE is Java runtime engine. So simple. To run Java, we need Java runtime engine. To run C#, we need CLR engine. To run PHP, we need Zend engine. So any language, you need that engine. So as long as you have that engine, it will run. Simple. So this, by using this concept, so you don't have to worry about whether I am running it on Windows, whether I am running it on Mac, whether I am running it on Unix or something. As long as this runtime engine is there, I am running everywhere. So when you compile a Java program, you don't get machine code, you get bytecode. Bytecode is a language which is understood by runtime engine. Okay. So why don't they directly run a Java program on Java runtime engine? Why do they need this bytecode? There are many reasons for this. So we'll learn. See, again, programming is something which we can't learn everything and do it. We have to learn a bit and we will get confused, and we have to practice it, and we have to move forward, then it will be cleared. So 90% of the stuff will be cleared at the end of the Java class. So don't expect that you will learn everything in the day one only. Okay. So Java program will be converted into another program called bytecode. That code will run as long as there is JRE. So do we need to install JRE? 99% of the machines will already have JRE. You don't need to install it. For example, if you have a Firefox browser, you have JRE. If you have a Google Chrome browser, you have JRE. We don't know. When you download Firefox browser, you automatically download JRE. Why? Because Firefox uses JRE to run it. Because Firefox contains some Java programs inside it. To run the Java program, it needs JRE. So it will package it inside the Firefox browser only, and it comes to you. So many people don't know that they have JRE, but they will be using other softwares. Okay. So the first thing is the platform independent architecture comes from runtime engines. So the languages today run on runtime engines. They don't run on machine directly. So a engine is not. So let's go and see in more detail. Then you might get a clear picture. Any questions until now? Okay. No questions. Okay, so forget about everything now. Come back to Java. What is Java? Is it a programming language? Yes. Is it a development environment? Yes. Is it a platform? Yes. Java can run everywhere. Even for example, mobile devices run Java. Even for example, point of sale systems, like if you go to Walmart and if you are purchasing something there, even in that point of sale system also Java will run. So Java will even also, it can run everywhere. Actually, almost anywhere. Even for example, if you have a navigation system in your car, Java is there too. So Java is everywhere. Okay. So Java is there on 3 billion devices. That's what they say when you download. Okay. So Java, see, another thing, why are we particularly learning Java? Why are we not learning C Sharp? Why are we not learning Python, Perl, or Ruby, or anything? We are not only learning Java, we are learning object oriented programming. We are learning programming and we are learning object oriented programming. So, by learning Java, we are learning the most popular language. So if we can do Java, you can do some other things. See, when you are expert at one programming language, you can easily understand the another one, and you can easily adapt to another one too. So that's not a problem. So we are not only learning Java, we are learning object-oriented programming. Okay. So Java is object-oriented. C++ is also object-oriented. Java is also object-oriented. But what is the difference between C++ and Java? C++ is platform dependent. Java is platform independent. Okay. And coming to Java, they say it's nothing but write once, run anywhere. Write once, run anywhere. Okay. Run everywhere. Okay. Yeah. All right. Great. Yeah. So there are many other concepts actually Java brought, like security, multi-threading, and distributed programming, and like that. We will see them later. Okay. So let's look at. Yeah. So for example, someone writes a program and they compile. Why do people compile a language into another? They want to convert it into binary, and also they want to check for mistakes. So compilation does two purposes. First, it will read your source code and tell that is there any mistake in it. So there can be two types of mistakes. So when you have a program, the program code is also called source code. Source code means the code which we write. So source code, when you compile, you can find mistakes. There are two types of mistakes: syntax errors and semantic errors. Can anyone tell me what is the difference between syntactical and semantical error? Syntax means like there is a spelling mistake or something, not grammatical mistake. For example, like you are not you are not your program is not in compliance with the syntax of that language. Okay. For example, if you don't write a semicolon, or if you don't public, yesterday the p was public, sorry, p was capital, so p should be small case. So in Java everything is small case. Agreed? So case sensitive, so public key should be written in small case. So these are kind of syntax errors. Semantical errors means it might look right in terms of syntax, but the program does something wrong. Means the program fails when you run it. So this kind of runtime errors are more of semantical errors. So you will know when we do that. Okay. All right. So this, in other terms, this is called compile time errors and this is called runtime errors. Okay. Let me write that down. It means you won't understand now, but compile time error, and this is called runtime error. Okay. Okay. Yeah. For example, see, the car looks good. If the car doesn't look good, that is compile time error. Car looks good, but when you start it, when you run it, something happens. That is runtime error. Okay. Yeah. So yes, Java, C++, and all these compile time languages are compiled languages like JavaScript, VB-script are interpreted. Means they are converted on the fly. While they are running only, they are converted on the fly to the machine language. Agreed? Alright. Yeah. So let's see. Okay. Now, if you remember, everyone should go and download JDK. Okay. JDK download. And you can actually get this link from Whitebox also. So everyone should do JDK download. You can get it from for Windows 32-bit or 64-bit. So everyone should download JDK. How many of you have JDK already? JDK, not JRE. Yeah. Okay. Yes, JDK 1.6. Yes. Okay. So everyone, if you don't have it, please download JDK. Okay. JDK, see, I said JRE, but now I am saying JDK. What is this? JDK is a set of tools to develop Java programs. JRE is a platform. JRE is an engine to run Java programs. See, for example, I am a common user and I want Firefox browser. I download Firefox browser. Means I downloaded JRE and I am running it on JRE. Do I know I have a JRE? No. I don't know I have JRE and I am running JRE, and because I am running a Java program which is inside the Firefox browser. I am fine. But for example, if I want to develop a Java program, I need a compiler, I need some other tool. So JDK is like a bigger set to do the programming. JRE is to run Java programs. People don't know, means to run a Java program, you don't need to know Java. Agree? So JDK is set of tools to develop Java programs. If you are developing Java programs, does that mean you also run the Java programs? Yes, of course. We develop to run it, right? So JRE is part of JDK too. Okay. JRE is part of, so if you have JDK, you automatically have JRE. So you don't have to worry about that. So if you see here, program files, and go to Java, and you should have JDK and you should also have JRE. Okay. So this JDK should be there. Agreed? So JDK has many tools. If you see Java C, this is a compiler tool. And for example, like let's say this is a jar, means you can create jar files using this. This is a Java console. This is Java DB, means you can talk to databases and everything. Like there are so many tools in JDK to do many things. Okay. So but when you come here, see these tools are there, but how do you use these tools? For example, when you double click, will it open? See, for example, when you click on Internet Explorer, it opens GUI. Okay, user interface. See, but does these tools have UI? No, they don't have UI. So if it is not UI based, what is it based upon? If it doesn't have UI, how will you use it from? Command line. Perfect. Prompt. Yes. Command line. So these are all command line tools. Agree? Command line tools. So how will you open a command line in Windows? Go and just type command. Okay. Or go to run and just do CMD command. So when you come here, for example, I want to use the tool called Java C. Okay. Now I know that there is a tool called Java C, but when you, for the first time when you are using it on especially Windows machine, when you type Java C, it won't recognize. Why? Because Microsoft doesn't want to support Java. That is one reason. but the reason is this command line does not know where to look for this Java C. Means it can't look all over the system for Java C, right? So you need to tell Windows that when I type something here, please go and look in this folder also. What is this folder? C program files Java JDK bin. So you need to tell Windows that if I do something in the command line, please look in this folder also. So how will you tell that? So that is called setting environment variable. Okay, so you need to, so if it is Windows, you need to set the environment variable. Okay, let's see that. So how will you do that? So you'll go and say environment variables, and you'll see the system environment variables, and you'll come and click on this environment variables, and you'll come to path. Path means please, means you are adding path, you are not replacing the existing path, because there are many locations. See, there are many locations it will look for. So you are adding one more location, telling Windows that please look here also if I type something. Agreed? And you'll put a semicolon at the end, and you'll copy this path, and you'll click OK, 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 and you will restart the command line. You will restart the command line. When you press this will show. So now command line knows that it has to look in that folder for anything I type there. Agreed? So for example, jar. See, it is showing me. For example, J console. Okay. So it will open the console, means it's a UI based, so that is why it opened J console. Okay, agreed. So J console actually is a testing tool, memory profiling tool. So let's not go there. Okay. Yep. Okay. So we know from the command line. So now, for example, I'm a programmer. Now let's think like we are all Java programmers. We want to write a program. So everyone, can we write a small hello world program? Everyone. How about now? Can you guys hear me now? Okay. Alright, open a notepad. Okay, open a notepad. Okay. So please write whatever I'm writing. Public class white box QA. Okay. So, and remember, public, everything is small. Class, everything is small. In white box, W is capital, QA is capital. Agreed? And I'll say public static. Static is, see, there is a single space. So I will give this program to you. Do not worry, you can copy paste. Okay. Args, but if you can write by yourself, that is good too. Okay. So public static void main string capital S. So here W is capital, Q is capital, A is capital, S is capital. Other than that, everything is small. And I will write system. S is capital. In system, S is capital. Okay. Println. And write this is my first Java program. Okay. And do file save as, and let's say white box, same, W should be capital, QA should be capital, and let's say all files dot java. Okay, okay, I will copy and paste it into your chat window so you can always reference this. Okay, now see, I wrote this program, close this, so it's whitebox QA.java. So first thing, we wrote the program in Java language. So we wrote the program in Java language. Okay, now we need to compile it. How will you compile it? So you need to go to command window. So there is a command called, you need to actually, if I am in this command window right now, which folder I am in? I'm in C users and a folder with my name. But where is the program? The program is in C training examples, right? So I need to go to this folder from the command line. So go to the folder where the program exists. Okay, so how will you go to the folder? You just do change directory cd and paste that directory, you will go to that folder. So right now I am in the folder where the program is. So what is that program? Whitebox QA.java. I need to compile it. So there is a tool called Java C, and the tool is inside this JDK, and you need to give Java C command and the program name, program file name. Okay, so if you do that, it will compile the program. So I will go and do Java C, and I'll say whitebox QA.java. So when I do this, what happened? The program is compiled. So this program is compiled and a new file is created. What is this new file called? Bytecode file. This is the bytecode file. So bytecode is nothing but another language. So Java program is converted to bytecode. So this bytecode I can take anywhere and I can run anywhere. For example, let's say I can run it on mobile phone. I can run it on like point of sale machine. I can run anywhere wherever there is JRE. So is there JRE on my machine? Yes, there is JRE on my machine. So how do you run this program then? So this is an example. So to run Java programs, so compiling means this is Java C. To run a Java program, just do Java and program name. Okay, so what is the program name? Whitebox QA. So I will do Java whitebox QA. See, this is my first Java program. So you compile using Java C command and you run using Java command. Agreed? You run the bytecode, you are not running this code. For example, I can delete this old code. Let's say I can delete this old code and I can put it here. Okay, and when you come back, it's not there. So you are running, when you do this Java whitebox QA, you are running the bytecode, not the original Java code. So the Java code is converted to bytecode. So bytecode is the one we distribute into programs. So the code we are running in Firefox is bytecode. The code we are running in Google Chrome is bytecode. But you might say that, why don't I see .class files when it is in Google Chrome or something? You can't see that because it is packaged into one exe. Exes, jars, for example. See, when you make softwares, people will make exe, jar, or what is that extension in for example, if it is Android package, or there is one more thing actually, and for example if it is Mac, there is another thing I forgot what is that. So these are nothing but, it's nothing but like a zip of program files. Okay, so this exe, jar, dll var, okay, these are all nothing but they are like a combination collection of this class bytecode files or any other files which contain compiled code. So is everyone clear about what's going on? Okay, actually I'm not speaking at all. Okay, give me 1 minute. All right, so that is the reason. See, here we are writing simple programs, so that is one file, but tomorrow like the programs will be collection of many files. Okay, okay, 1 second. So this path setup can be done only once. You don't have to do it every time. See, the path setup is not about this compilation of this single file. The path setup we do is to tell Windows where is the Java compiler. Sujaya is saying that why can't we name our files, like for example this is whiteboxqa.class, right, or whiteboxqa.java. So can we name like abc underscore whiteboxqa like this dot java? Yes, you can do that, but the program inside, see this Java file, this is a Java file, right? So if you open this, this is the name of the file and this is the name of the class. See, this is the class name and file name. So the class name should be same as the file name. As long as you have the class name same as the file name, that is fine. Okay, and Anuradha, remember the setup we have done. See, once you install JDK for the first time, you know that you install JDK and you have compiler, but does Windows know it where the compiler is? So when you go to command line and when you say Java C, does Windows know where is the compiler? No, you need to tell Windows that this is the place where the compiler is. So you are going and linking the Windows command line to the Java compiler. That will be done only once. Okay. Yeah. So everyone, please try to write this program. This is very important. Sujaya is saying that are we linking where the compiler is or where we store the program? No, only where the compiler is. Sujaya, if you remember, I have linked this compiler to the command line even before I wrote the program. So this has nothing to do with the program. Okay. So coming back, there is something called JVM. See, JRE is a bigger set, JVM is a smaller set. So if you see, how do you compare JVM to JRE? So JRE is a bigger set. So JRE is like, it contains JVM plus code verifier plus class loader plus garbage collector. Okay. So Anuradha, I did not get it. So if you are saying that there is a file which cannot find, that is different. It is telling that means it cannot find Java C file. So it cannot find anything, any program which is relevant to Java C. Yeah, we only do that once and it will be there. Okay. Yeah. So let's see. Again, coming back to JVM and JRE. For example, see, I wrote this white box QA dot Java program. Agreed? This is a Java program. When I compile, I got what? White box QA dot class. What does this contain? This is bytecode. Agreed? This is, what is this called? This is Java code or source code. We also called this as source code. Okay. So programmer wrote this. When you compile, you got this one. Okay. Agreed? When you compile. So when you run this program, when you run this program, this will be converted to binary. This will be converted to binary and we get result. Agreed? We get result. Agreed? Who is the one? So we see, generally when you run this, it will be converted to binary. So remember, we have been telling this from that bytecode will run everywhere JRE is there. Agreed? So bytecode is the one like as long as there is JRE, bytecode will run. So someone is converting the bytecode to binary. So who is the exact person doing that? JVM. So JVM is the one. See here, this conversion is different. See, let me show that again. Java to bytecode is different and bytecode to binary is different. Agree? So Java to bytecode compiler is doing that. Bytecode to binary JVM is doing that. But JVM is part of JRE. So that is the reason people will say JRE or JVM. It's up to them. So most people use these two words similarly, because most 90% is similar, but only like JVM is like a bigger set than JVM. JRE is like a bigger set than JVM. But if you don't consider this, many people don't consider this because they don't really name it or they don't say it. Because many people don't consider this as really functions. So that is why JVM and JRE are same. But actually, if you see particularly, JVM is the one who is really converting the bytecode into binary. Okay. So then what is this class loader, code verifier and garbage collector? Let's see that. First one is called class loader. Okay. Class loader. Alright. For example, let's say I have a C program and I compiled it. What will I get? I'll get binary. So you run binary directly. You will run binary directly. So you don't need any runtime engine or anything because it's already binary. I have a Java program. I compiled it. What do I have? What do I get? I have bytecode. And you convert this into binary using what? So there is JRE and you convert it into binary and you are running it. So it will run. Okay, it will run. because it's this all this part from running this byte code is all part of running. Here only directly this just running the binary. Here from byte code we run it. So when you want to, for example, I want to, let's say, see, I want to read something. Let's say, yeah. Can anyone tell me what is loading? What does loading mean? For example, you are watching a YouTube video, it will tell that it is loading. Or if you are opening a file, it tells that it is loading. What does loading mean? Bringing the file, downloading from server or database. And where is it putting then? Where is it putting? If it is downloading from internet, somewhere else from server, and if it is getting it from somewhere, where it is putting? In your local memory. Yes, in the RAM. Means it is putting in your local memory. Okay. See, right now, where is this file? Where is this file? It's in hard drive. When you open this, where is it? It's in my RAM, so I can read it. So putting this into RAM to read it, that is called loading. Agreed? So similarly, for example, when you want to run, for example, let's say, when I say Java whitebox QA, someone has to take this whitebox QA.class and load it into memory so that my JRE can read it. Am I right? So JRE wants to read it. JRE won't go to hard drive and read it, right? So someone has to take it from here and put it into memory. So that person is called class loader. So the class loader is nothing but the person who loads into memory. The loading the class into. Here we have only one class, but tomorrow we might have 1,000, like many classes. So class loader loads all the dot class files into memory. Agree? Then there is code security. Okay. Yeah. For example, I have this file, dot class file. See, for example, first I wrote this dot. Yeah, first I wrote this .java file. If you remember, this is the program a developer wrote or a programmer wrote or a tester wrote. So this is the program which I wrote, right? Agreed? So I wrote this program. But what happened after that? I compiled this and I got this program. Okay. Tomorrow when I want to sell this program, think like this is a really wonderful program where I can sell it and make money. And if I want to sell this program, will I give this .java or .class to other people? What will I give to other one? Will I give .class or .java if I want to sell it? .class. See, is Google Chrome giving you the code or is Google Chrome giving you the compiled program? Is Microsoft Office giving you a program code or compiled one? Compiled one. Everyone will give compiled one. Why will they give you source code? If they are giving you source code means you can duplicate it. Simple. Means if people exposed source code, see, that is the reason. Open source means the code is open. They won't make money. Unix, no one made money, but still popular. Microsoft, Windows, it made more money, but it is a buggy program. Agree? So perfect programs are open, but there is no commercial value in it if you open it, right? So if you give your source code away, what is the means? There is nothing you can make out of it, so it's given already. Agreed? So source code, so generally people don't give source code out, so generally they give the compiled code out. Agreed? So remember here, I have a C program. Agreed? I have a C program and I will compile it. Okay? What will I get? I get binary. I have a Java program. I compile it. What will I get? I get bytecode, right? So bytecode is another language, just another language. If it is binary, it is hard to read, right? If it is binary, it is hard to read. People can't really, for example, if I have 100,000 lines of program and if I compile it, how many lines it will be in binary? So many lines in binary. Do you think people can read that binary and understand what I wrote? No, there is no way you can do that. Agree? So once you convert it into binary, it is machine readable, not human readable. So they can't duplicate my program, they can only use it. See, if I give you Google Chrome software, can you create a Google Chrome or can you use Google Chrome? You are using Google Chrome, you are not creating another Google Chrome browser or any other browser. So similarly, so when I give a compiled program, binary program, you can't do that. For example, if I give this bytecode dot class file to you, so if you open this and let's see in the notepad plus plus, see this is not really binary, but it is not really, see this has, this is my first Java program, Java IO, whitebox QA.java, and if you see there are some, line number table, so there are some things which we can read actually. So it is not really 100% machine readable. It is not really 100% human readable. So it is somewhere intermediate, between the human and machine. Agreed? So now because this is more human readable, Java is human readable, we converted it into intermediate. And when you run this program, this will be converted to binary. Agreed? This will be converted to binary by whom? JRE. So if I give this program, so for example, I will give this program. Think like you can change, see for example, you can go and add whatever you want, right? You can go and add whatever you want. So people can change your bytecode. So for example, think like I really wrote a cool Java program, I compiled it and I asked you to deliver it to some other person. For example, in between you got a crazy idea that you will change the program and you'll open my .class file and you will add some garbage here. Why? Because when this .class file goes to the another person, when he runs it, it won't run it because there is garbage in it. But do they really know it was modified by someone else in between, or really I wrote the garbage? So how would you know that the code did not change after compilation? Okay, so how do you know the code did not change after compilation? How do you know the code is secure? Code security. How do you know that the code is secure, that no one changed this code from the time it is compiled? That is called code security. How will you know it? Okay, for example, think like I wrote a letter for someone and I asked you to deliver it. How would I know that you haven't read that letter? Or how would I know that you didn't add anything to that letter? For example, think like I'm sending a letter to person 2. How would I know that the person got exactly what I wrote? Nothing more than that, nothing less than that. Okay, seal it. Do you think by see? First of all, how do I know that the person who received, the person 2, like I'm the person 1 and there is person 2. The person 2 who got this letter did not get more than what I wrote, did not get less than what I wrote, and got what I wrote. By comparing both copies. So here I wrote only one letter. There are no copies. Okay, by comparing the received one with what? With the sent one. No, there is only one letter. See, I wrote that letter and I am giving you that letter. By checking with other person, with which person? The person who received it? Yes. So you are telling me, for example, simple. If I am writing a letter to you, I will call you and I will ask that, and I will read that letter again to you and I will ask that, did you get the same letter? Am I right? Yes, this is what I exactly got. The other person will confirm it. This is what I exactly got. So this is secure, right? You write a letter and you call them and you'll read that letter again and you'll ask them, did you receive this, right? This is a good way. Means it is really a secure way. Do you agree with it? Yes. But don't do that in real life because you don't have to waste time in writing. You can rather do phone call. But in programs, there is no other way. Yes. So I have a Java program. Okay. So think like this. I have a Java program. Let's say this is a size of, let's say this is a size of 10 lines Java program. I compile it. What will I get? I get bytecode. But this will contain 15 lines. Do you know why? Or 15 or 20 lines. Let's say 20 lines. Do you know why? Okay. So can anyone tell me what is metadata? Data about data. Very good. Okay. So see this one. I wrote Java program. Right? I wrote a Java program. What does this program contain? Let's say, let's open our Java program. Okay. This program contains a class called whiteboxQA. It contains a method called main method, and it contains a line called system.out.println, and inside this is my first Java program. Agree? So now, when you compile this program, the compiler will read all this. The compiler will read all this and it will create two sections. One is called header, one is called body. Okay. First in the header it will say that I am compiled using JDK 1.6. Okay, it will tell in the beginning that I am compiled because it knows which compiler is compiling it. So it will write, see, there is a Java program. This program is there. WhiteboxQA program is there. Okay, WhiteboxQA program is there. Now this is the bytecode. This is the bytecode which is generated. So the compiler is creating this. So when you compile this, it will first write in the header that I am compiled using JDK1. Then it will say, it will convert line by line into bytecode. So it will convert this into line by line into bytecode and it will write this bytecode here. Okay. Then it will write in the header, this code contains one class called whiteboxQA. This class contains one method called main method. This method contains one statement, means one line, println. Agreed? So this is there. Now, who will run this bytecode? Where will you run this bytecode? Who is the one who is going to run this bytecode? Please tell me. JRE, not JDK. JDK is to develop it. JRE is to run it. Agree? Remember, bytecode can run anywhere as long as there is JRE is there. Bytecode will be converted to binary by JRE. Means of course there is JVM inside it. Am I clear? So, see, who created Java compiler? Java people only. Who created JRE? Java people only. Right? So now, this JRE will take, so when you run, see, I remember, first thing is, I wrote this byteboxqa.java and then what did I do? Java C whiteboxqa.java. See, simple. I wrote this whiteboxqa.java and I am compiling Java C whitebox. All this thing, bytecode, header, body and everything is created. By whom? Java C. So this contains, see, this only contains code, but this contains converted code, the header information and so much of metadata. This is called metadata, right? This section is called metadata because it is explaining data about data. That's what you told me, right? So now, when you run this program, how will you run this program? Java Whitebox QA. Who is running this? JRE. So when JRE is running this, first before when you press enter, first it will come and read this header. Oh, you are compiled by JDK 1.6. Okay, I am also JRE 1.6. I will run you. Not a problem. Okay, and it will read this. This code contains first one class called whitebox QA. It will go and look in the body. Oh, is there whitebox QA class? Yes. This code contain main method. Oh, is there main method? Is this code contain println? Means it will verify the data with metadata. If the data is not consistent with metadata, what does that mean? Someone changed it, right? If the data is consistent with metadata, then it will verify and it will run. But if the metadata is not consistent with metadata, it won't run this program at all. So if you change bytecode, Java will know it. But you might say, any person who is really changing this dot class file, can't they change metadata? You don't know, because only Java people know how to write metadata, and only JRE knows how to read metadata, because both of them are created by Java people. No one else knows how to write metadata. They only know how to write Java or IL code. Okay, so this way code is secure. So even though you change your code, if someone changes your code, everyone will know it. So did I make it clear? Okay, all right. So the first thing is class C. JRE contains many things. JVM, which converts bytecode to binary. Then there is class loader, which loads all the classes into memory, right? Classes into memory. There is code security. You know what it does? Metadata to data checking, right? To data check. Okay. And the next thing is called garbage collection. Okay. So can anyone tell me what is garbage collection? In programming. I don't want it in real life. Okay. What is garbage in programming? No, garbage is not errors. Variables which are not used. Kind of, but not exactly, Sujaya. To avoid memory leakage, what is leakage? What is memory leakage? See, people will tell that memory leakage. But where is memory leaking? Can anyone tell me? So do you see anything leaking out of your machine? What is memory leakage? Collects unnecessary data. So for example, see, think like human memory is very powerful. It can store so much of data. We don't even use 1 by 10th or 1 by 8th of it too. But think like we have very small memory. Like for example, you can only remember day stuff, like what happened in last 24 hours or something. I'm not trying to tell you a film story here, but what I'm trying to tell is like, if your memory is limited, that you can't remember like 10 years back, or you can only remember one day back. If you can only remember last 24 hours, you would prioritize what to remember, and you don't try to, for example, you can only remember 10 things or 20 things in a day, right? You will prioritize. You don't want to really remember which you don't want to remember, or which is not really useful for you in future. Am I right? So generally what happens like that is like, for example, I want to go to bank and I want to remember that I have to deposit some money into my friend's account. But once the task is done, I want to forget it, because so that I can remember something else. So anything which is done, I want to forget it. Means I want to clear it from my memory. If even after it is done, if it is staying in my memory, it is garbage. Don't you think so? Even after the task is done, if it is still staying in my memory, means I am not using that memory for something else in future. Means that is garbage. Means see, don't take it literally, but see, RAM is RAM is very limited. Our machines have very limited RAM. So if a program is running it, as long as it running is fine, but it finished doing something. If it is finished doing something, if it doesn't need something, it should not put it in the RAM, because our RAM is very useful. Because see, we are running all these programs in RAM. Not only how many, let's see how many programs are running currently in RAM. This is process, but see memory. Yeah. See, this many programs are running in our RAM. So if, for example, Google Chrome is not, for example, think like I opened this tab. I opened this, let's say, let's look at the Chrome, see, 348, 380, see, I open a tab, automatically memory will increase. Somewhere memory increased. Agreed? For example, let's see GoToMeeting recording. Otherwise, GoToMeeting recording. See, I am recording each and every second. So that is the reason memory is increasing. But think like I am stopping the recording. I close this webinar. If it doesn't go away from my RAM, that means there is a leak. Means even though I am not doing it, even though I am not using it, that is still occupying my RAM. That is leak, garbage. Agree? So generally, in the program, see, in the program, we create memory. We create memory. For example, let's say in program people will say int I equal to 10, means they created a memory. Means once the program is done, or once we don't use I, we have to delete I. So in C++ language, in C++ and other languages, developers create memory. Means actually there is nothing like creating memory, because if I have 4 GB memory, it's 4 GB only. I can't add another 4 GB from my program. It's a physical, right? It's hardware. I have to buy it and add it. I can't add it in from a program, right? So similarly, developers allocate, it's not create, allocate memory and deallocate memory. So in the program only they will tell that please assign me this much memory and please remove me this, so free up this memory, so deallocate memory. So it's developer's job in all old languages, so C, C++ and everything. Developers create memory, allocate memory, developers deallocate memory from program. Agreed? From program. Agreed? So think like, let's say for example, yeah. So it's a good way and it's a bad way too. The reason is sometimes developer will allocate memory and he will forget it, because humans make mistake. The programs will be many bugs. Means if there is a problem, there is a bug. You know that if there is no bugs at all, there is no point of having this testing course at all. Agreed? So developer might allocate memory and he might forget to deallocate. Agreed? Sometimes developer might allocate it, deallocate it, and he forgot that he did not deallocate. Means he created, he removed it, but he forgot that he removed it and he is trying to access it again. So bugs will happen because of that. So simple, don't clean up your own mess, because you are not good at cleaning up your mess. Simple. So Java created a special program. It is, you just allocate memory. The program which is called garbage collector will come and release the memory which you are not using. Okay. Think like, for example, you can create as much mess you can. Java, the program will come up and it will clean up your mess. So this way Java is a good programming language, because programs are always made of mistakes. So if someone else is cleaning up your mess, that is good, not bad at all. Right? So these are the four things which Java gave. So JVM, so we have bytecode, we have JVM, we have class loader, we have code security, we have garbage collector. Okay. Any questions regarding this? Any questions regarding this until now? And Srivalli, garbage collector is a separate program, it will run separately. So it has nothing to, yeah, it has nothing to do with the program itself. So when you have programs running, this program will come separately and it will run later. Yes, Java program is converted into bytecode and then into binary. Yes. Okay. Yeah. So I will ask you one question. There is C program. You compile it. You get binary. You just run it. Agreed? Then there is Java program. You compile it. You get bytecode. And you run it. When you are running it, it will be converted to binary, bytecode to binary, and code security check, and it will run binary. Agree? It will run binary. So which one will be faster? Will Java will be faster or C will be faster? Yes, C language is faster. Simple. It's already binary, you are just running it. You are not doing any other further conversion here. Here you are doing again some conversion while running it, and you are doing 3 steps here. It is only 1 step here. Automatically the first one will be faster. So this is kind of like setback for Java. Then how did Java solve it? So if it was still a setback, Java wouldn't have been popular. So how did it solve it? So there is something called, for example, this is for a single file. For example, I have 1000 files. Agree? Same thing. So you are running the 1000 files. Am I right? You are running 1000 C files. You are running 1000 Java files. Agree? So when you compile, you get byte code. So you get 1000 byte files, and you have to convert all the 1000 byte files to binary. Agreed? It is one binary file. Agreed? And this is 1000, and one binary, just you will get one binary file. So the time which is wasted in Java, conversion from byte code to binary during runtime takes time, right? Takes time, consumes time. So this 1000 byte codes files to binary is the 1000 byte codes files to binary is the biggest thing which consumes time. How can we reduce it? Remember, Java will not convert everything from byte code to binary. So let me show you here. See, you compiled Java, you got byte code. This byte code is loaded in here, byte code verifier, and it will be then converted into binary. Agreed? Now if you see here this byte code, if there are 1000 files, it will not convert this 1000 files into this binary. There is something called just-in-time compilation. So this is called a JIT compiler. Okay, it will take as needed basis. Okay, let me tell you one thing. Okay, I have 1000 Java files. I got compiled. I got 1000 byte code files, means class files. Let's use class files from now. Okay, so now when I run it, I have to convert all these 1000 class files to binary, right? So this takes time. In C you don't have that, you directly have binary and you run it. But in Java you have 1000 class files and you have to convert them into binary. You have to verify all of these 1000 class files and you have to convert them all of them into binary. So this is the one who is taking time. But in Java it won't do that. It will only take the first file, okay, and it will convert it into binary. And if this file uses another file, for example in this file you call some print function, and if you are using that print function, it will go and take the another file and it will get the another file and it will take the another file and it will then convert it into binary. So what does it mean is, it will not convert all the byte files into binary just for the sake of it. Means as the program needs a file, it will goes and gets that file and it will then convert it into binary. This is called just-in-time compilation. So it goes and gets the class byte code file as needed basis and it then compiles it. So this is called just-in-time compilation. Okay. So this concept, so now can anyone tell me like which one will be faster, C or Java? You can't really tell because they are different architecture. If it is one file, you might see C by milliseconds, not even milliseconds, fractions of milliseconds. C better than in some. If it is like huge files, you don't know. Java might be better sometimes. It depends. We can't tell. But Java is not slow. At least we can tell that Java is not slow, right? So that is what means. It is comparable. At least it is comparable to C now. So that is the reason. See, Java brought many things to the programming world. So, but its main drawback used to be speed, and because of just-in-time compilation, the speed is very much similar to C language because of this concept. So that is the reason it became it sustained. Okay, so there are three major things which JRE does. First one is loading the code, second one is verifying the code, and third one is converting them into binary and executing the code. Okay, yeah. So now where did we write our program? What is the editor we used to write the program? That is Notepad. Means we just used Notepad to write our programs. But do you think like if you have to write 100 files or 1000 files tomorrow, Notepad is a good software so that we can write our programs? No. We need some program or we need some tool to make our coding or programming easier. So these are called, generally they are called editors, or they are called IDEs. IDE means integrated development editor. So IDE means integrated development editor. So we need some IDE tools where our programs will be easier. Why? Because if we type something wrong, it will automatically tell that there is a syntax error. So they guide us. They guide us in syntax. They will write code. They will write code for us. For example, if you press dot, it will tell what to use. So you don't have to type everything. So they will guide, like if you type half of the word, it will finish the word. So they will help us to write code, right? And another thing is all the tools are at one place. So it's all so we don't have to go to command line. Do not have to go to command line. All tools integrated in one place. Okay, so the IDE we will be using for the rest of this Java classes is Eclipse. Eclipse is open source, means it's free. Okay, it was actually created by IBM, but later it was taken over, means Eclipse itself became a separate group. Okay, so go to Whitebox QA, go to testing tools page and find Eclipse, and if you see this Windows 32-bit or 64-bit, so depending upon that, download it. For example, mine is 32-bit, so I will show you how to do that. See, it's a zip file, so it is getting downloaded. Eclipse is like not a software which can be installed. See, and you see it has Eclipse, Java and everything. So I take this folder and I want to put it in a place where I can access easily. See, in training I will put it here, Eclipse. Okay, so if you want to start Eclipse, it's not like a regular installation, it is like a copy. So you get a zip, you extract it and you put it in a folder where you want it. So in training I put this Eclipse, and if you see this blue icon, this is what Eclipse is. So if you double click it, it will start Eclipse. And it will ask you what is the root folder where your all the code should go in. For example, like this is the folder where, for example, say this is examples. Say I want all my code from Eclipse should go into C training examples, and please use this as default and don't ask me again. Okay. Agree? So it will open with a welcome screen. Close this welcome screen, so it's like a tab. Okay, so then if you see, this will have like task list. We don't need task list, you don't need outline. So this is how Eclipse looks like. So you get a welcome screen and you should close it, and you should close any unnecessary tabs. And see, this is Java, means it is ready for Java coding. But you can go and select, like if this is not Java already, go to window, open perspective and go to other, and always select Java default. This is Java. So go to window, go to open perspective, go to other and go and select Java. Okay. So this is Java. So I have set up this Eclipse. So you can close this. You can close this. For example, I close this. If you want to go and open it again, where will you go? You have to go to the same folder again. You have to go to Eclipse again. You have to click this blue icon. So but going here and clicking this blue icon is always painful. So what will I do? I will say that, right click it and I will say that pin to start menu. So if you see here, it automatically came here. So if I click the start button, it automatically came. So I can directly click from here. It won't ask for that folder again. Okay, it will just open Eclipse. Okay. So now, see, Eclipse is an organized way of creating code. So when you are doing a Java thing, first create a project. Create a project first. So let's create a project first. See, I'm recording this, so you can use this recording. Go to file, new project. I will say Java project. So go and create file, new Java project. Agreed? Agreed? So and I will say this project as, let's say, okay. So if you see, this is Jan batch, and in this project, go and create a new package. See this one, on right click on this project and new Java package. So go and create a new package. So right click, new package, and package name should be always like edu.wbqa.basic. Okay, like you will edu.wbqa.basic. Okay, I created a package. On the package, right click. Okay, right click on package and new and class. So create a class now. So right click on the package, new and class. Now let's say we want to create, let's say, white box QA again. White box QA. See, same thing as before. And say that I want public static void main. Public static void main. Check this box. You don't have to check it. You can check it. It's up to you. Automatically Eclipse will create the code for you. See, public class white box QA, and it put the package. See, just like before, same thing like before. See, let me delete these comments. These are comments. So just like same code like before, if you remember. Same public class white box QA and public static void main, everything is there. Here inside this you want to write a line. System, see, capital S, out dot C. Automatically it is guiding me what to write, and I will say this is my second program. This is my second program. Agreed? And you want to compile it, you want to run it automatically. Eclipse automatically compiles it. By when you save it, if you are going to save it, it will compile automatically. And you want to run this program in the, you don't have to go to command line. You have to just click the run button here, and it will show the result here. That console window here only. This is my second program. So everything is at one place. Agreed?